Hi.
Oi, so they give access to their job portal, Geeks for Geeks, for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way!
Oh, yes, Wiz. Don't delay. Enroll now.
Geeks learning together.
So, hello everyone. A very good evening to everyone present here. Just give me a confirmation in the chat box that I am properly audible and visible so that we can very quickly start. Hello Pavan, how are you? Hello Ajay. Hello Ashutosh. Yeah, just give me a slight confirmation that I am properly audible so that I can very quickly start. Yeah. A very good evening to everyone and welcome to today's session. And yes, thank you, Pavan, very much. So, yeah, do write your names in the chat box. I see around 10 people are, around 33 people are live with me. So, do write your names in the chat box so that I could get to know your names, or just do a +1. That would suffice. Hello, Karthik. Hello, Pavan. Yeah, Pavan, just write a +1 in the chat box. Okay. So, yeah. And a few pointers before we start. I would really appreciate if you all could interact with me while we are progressing in the session. That would very certainly help me. And at the same time, it will help you as well. Okay. So today is the day 7 of CodeCamp, and this particular series we have brought at Geeks for you all, so that you could basically get into a habit of solving coding questions on a regular basis. Okay, so you must be seeing Siddhartha and Yash in the first 6 days, and you must not have seen me on this channel on a recent basis. But I am also a mentor at Geeks, and I will be introducing myself shortly. Hello, Ashish. Kindly do not spam. Just one single +1 is good. Okay. So let me just share my screen and then we will start. Just give me a minute. Yeah, I hope my screen is very properly visible to everyone out here. Okay. Yeah, hello Ashish. So let me just change the layout, which will basically be helpful for you all. Okay. So yes, I think my iPad screen is very properly visible to everyone. Okay, hello Raj. Yeah, so those who have joined me in this particular live session, can you please write that whether you will be appearing for your internships or your placements in the coming internship and placement season? And how are your preparations going on? And what are you presently doing? I hope that everyone is properly doing their preparation. If you are having your interviews in the next few months, I'm sure that many of you would be having your internships and your placements in the coming next month or so, in the month of July and August. Okay, summer holidays. Currently, I'm doing an internship. That's great, Pawan. I am also currently doing an internship right now. Okay, so yeah. Let me give you a small introduction about myself and then we can start. My name is Gaurav Kumar Shaw, as I have already written on the screen if you could see. And I am presently in my final year at IIT Kharagpur. My final year hasn't started yet. It will start from August onwards. Currently, I am doing my summer internship as well at Cultfit. I'm sure, do you guys know about this particular company, Cultfit? I'm doing my software engineering internship there, and I am working as a mentor at Geeks for Geeks for a very long time. And I have had quite an experience in delivering content related to data structures and algorithm. Okay, so if you could have a look at the previous videos at Geeks for Geeks in the month of March, February, and December, I was pretty much active on this channel, in the practice channel. Okay, so yeah, thank you, Ashish. Yeah, learning DSA for placement. That is great, Shubham. Pawan, you are in final year. Yeah, I will also be starting my final year very soon. Okay, so this is a small introduction about me. And apart from this code camp, like we are on the seventh day of this particular series. And if you guys remember, and if you guys are following me, or if you guys are following the channels of Geeks for Geeks, we do bring series as such. We had graph series, we had DP series, all those particular series we keep on bringing for delivering content to our audiences. Okay, so if you're preparing for your internships, you can also check out other courses at Geeks for Geeks. We have a CIP course, which is basically a complete interview preparation course. And we also have a course called the Geeks for Geeks self-paced course. And recently we have launched a comparative programming course as well. Okay, so comparative programming course, which is basically the CP course, if you like to call it in that way. So that would certainly help you in your online assessments of your internships and placements. And in fact, I have worked as a problem setter in those particular courses, and I have added my own problems there. And I keep on adding that. Okay, so this was about the courses. Do check those out. Live course, just have a look at the website. I'm not really sure about all the live courses going on. You can check out at the website and you will get to know. Okay, so yeah, so let's continue with our series, that is today is day 7th. And if you could have a look at the description, today is basically we are going to study about advanced sorting algorithms, and we will be doing a few problems as well. Okay, so I don't think there has to be anything advanced related to advanced sorting algorithms. Anyone tell me, what do you guys think when I say advanced sorting algorithm? What algorithm comes to your mind? Pawan, Ashish, Shubham? Yeah, I would really appreciate if you guys could make the session a little bit interactive in the chat box. Yeah, heap sort, merge sort. Okay, so that quick sort, that is also good. In fact, we have a really great set of sorting algorithms. Okay, so the simplest one are the insertion sort, bubble sort, and selection sort. Right. So can anyone tell me the time complexity of these particular sorting algorithm? Selection, insertion, and bubble sort. What do you think is the time complexity of these algorithms? Can anyone tell me? Merge sort is really a good sorting algorithm. That's great, Pavan. Actually, if you guys know, is that merge sort is a very common algorithm. Everyone has heard about it. It's an n-log n algorithm. But the important part and the beautiful part about merge sort is that there are various questions of very hard level that can be solved by the concept of merge sort. Okay, you will basically find the concept of merge sort being applied on linked list as well, and these are very popular interview questions. Okay, like it's a very like there is a very less chance that someone will ask you radix sort or some very advanced or very lesser known sorting algorithm. But if they are asking a merge sort, it means that they are checking your concept on recursion and how very well you understand the concept of recursion and the merge part of the merge sort. Okay, in fact, we will be discussing merge sort in great detail today, because the third problem that you guys will be doing today is based on merge sort only. Okay. Okay, yes. Yes, Rishabh, Ashutosh, and Pavan. Yes, you guys are correct. The complexity of these codes are big O of n square. Okay. So, and what exactly is the complexity of merge sort? Okay, yeah. So, do you guys have the problem links as well? The problem which we will be solving today. Okay, okay. In that case, let me just give you a small brief idea and then we will continue. Okay, yeah. So, before I move on to solving the questions, let me just tell you that these sorting algorithm have a time complexity of big O of n square, and merge sort is a very popular sorting algorithm which has a time complexity of n log n. Do you guys know that we have a sorting? We have a predefined function called sort function in the C++ STL. Can anyone tell me what is the time complexity of that particular algorithm? Yeah, n log n. Yeah, that's great, Ashish. N log n. In fact, n log n is one of the best time complexity. Shell short, I don't think. See, what I would recommend you is that you understand the basic sorting algorithm in a very, very great detail and have a go through about how exactly these algorithm work. Shell short, radix short, count short. Okay, heap sort is very important. Okay, so heap sort is important. I would recommend to learn heap sort because the application of heaps are very important in from interview point of view, how you can basically create max heap, min heap, and using priority queues, and the implementation of these are important. So make sure you learn these. But the other sorts like radix sort, count sort, I don't think these are very important because no one will ask you to implement. But in fact, you may be asked verbally to define what exactly is radix sort. So you just have an overview. Okay, but do learn all the time complexity. Okay, learn all the time and the space complexity and the and the concept part of, okay, concept part of these algorithms. Okay, not very in detail about how you can code everything, because yes, just go through. In fact, if you Google all the sorting algorithm, you will find a Geeks for Geeks article that basically lists down all the sorting algorithms. Okay, and just you can then keep that on revision mode. Just revise a few times on a regular basis. Okay, yeah. Okay, so let me share the questions now, and then we will. So the first problem that we are going to do is the. Do you want me to do the easy problem first or the hard problem first? In fact, let's do the easy problem first because I suppose if I start with the hard problem, many audience I will lose the audience out. So let's start with the easy problem. So I have sent the link of the first problem in the chat box. Okay. Yeah, Poonam. We will be starting with the easy problem as usual. Okay. I see 40 plus students are live with me. I would recommend you all to kindly be interactive. Okay. So let us read the problem statement first and then we will try to um solve the question. So let me share my problem statement screen. Yeah, the name of the problem is chocolate distribution problem. Okay. So let's see what exactly does this problem say us. I hope everyone can see my screen. Okay, yeah. So I do have the solution code pasted, but there is no point in looking at the solution code because I will be helping you go through the naive approach, brute force approach, and then we will discuss the optimal approach. Okay. So there is really no point in looking at the solution code. That is just for my explanation. I will be explaining it to you at the end. Okay. So, but first let's read the problem statement. So what exactly does this problem statement say? In this question, you are given an array A of positive integers of size n, where each value represents the number of chocolates in a packet. Okay, so each packet can have a variable number of chocolates, and there are m students, and your task is given to distribute these chocolate packets among the m students such that each student gets exactly one packet. The difference between maximum number of chocolates given to a particular student and the minimum number of chocolate given to a particular student is minimum. Okay, so let's have a look, read at the problem statement, few examples here. So let's say I have got 3, 4, 1, 9, 56, 7, 9, and 12. Okay, so I have got so 8 positive integers, and 8 positive integers is basically representing the number of chocolates in 8 different packets. Okay, but I'm not supposed to give all the 8 packets to all the 5 students because in the question it is mentioned that each student should get exactly one packet. Okay, So it means that I pick up a packet, I choose any 5 packets from these 8 packets, and I distribute those 5 packets to these 5 students, exactly one. Okay. Now the question is asking us that I have to find a difference between the maximum number of chocolates received by any one particular student and the minimum number of chocolates received by any one particular student. And this difference I have to minimize. So when I say I have to minimize this difference, it means that I have to choose those particular 5 packets in such a way such that this particular difference is getting minimized. Okay, so just have a +1 in the chat box if you had with me till here. Okay, if you have understood the problem statement, just do a +1 in the chat box and let me know. Okay, that's great, Pavan. Hmm. So, do you guys are getting any kind of ideas in your mind that what exactly will be what we will be applying in this question? And in fact, yes, that we are having doing a session on sorting. So definitely, the idea of sorting will be used. Okay, Shubham. Okay, Rishabh. That's great. Yeah. Just let me know. Yeah. So, what ideas are you guys are having presently coming up in your mind related to this particular problem? Sort and single pass. Okay, let's see. Yeah. So just have an intuition that in the question it is said that we have to choose any 5 packets out of the 8 packets. First, let us have a look at the constraints. Okay, in the constraint it is said that n is around 10 to the power 5. Okay, and ai is around 10 to the power 9. But the number value n, m is the number of students is less than n, less than or equal to n. It means that I will always have the number of students either less than the number of packets or equal to the number of packets. Okay, it doesn't mean that the number of students will be greater than the number of packets. In that case, I won't be able to distribute the chocolate packets. So the constraints make sense now. Okay, I hope this part is clear. Now we have to think of an optimal way to take these particular m packets out of these particular n packets and distribute in such a way such that the maximum minus the minimum is always the minimum. Okay, is always minimum. So I hope everyone has properly understood this code. So let's get back. First 5 major packets distribution. So do you think that the first 5 will always work? Okay, so let me share my iPad screen now, and we'll move to the understanding part of solution then. Just a minute. First M, like any first M, I don't think. Why do you think any first M should work? What is your logic? We will find difference between each packet and then distribute pack. Poonam, I don't think this is a really good strategy to go about. Okay, so let's have a look here something. So can anyone tell me? Okay, yeah, let me just include a new page here. Hmm. Okay, so basically, we have a our array is of size n, and we got m students. Okay, so basically, let's say, and n is always less than or equal to n. So we got n packets, and we have to distribute this among m students, such that every student gets one single packet, right? And the difference between the maximum minus minimum, we have to minimize this. Okay. So without going into very great detail, let us just try to understand in a common sense way. Okay. So let's say I've got an example some here as well. Let's say our example initial array is equal to 7, 3, 2, 4, 9, 12, and 56. Okay. And m is equal to 3. Okay. And n is equal to 8 in this case because we have got 8 different packets and we have got 8 different values, right? So now we are asked to distribute among 3 students. Okay. So which of these particular makes sense? Okay. So tell me, the problem statement is basically something like this, that we have to optimally choose m packets out of the given n packets such that the difference is minimum. Okay. So can anyone tell me how many subsets I can form basically? How many different subsets I can form out of size m, subsets of size m out of n packets? Can anyone tell me? Ashish, Poonam, Pavan, Shubham, Rishabh? The question is somewhat similar to this, right? Like you have to choose you have to choose m different packets out of these n given packets, and you have to distribute them, right? And you have to make sure you have to choose optimally. So a naive solution, what I'm telling you all is that we can have a naive solution. Okay, just the common sense solution. What exactly is the common sense solution? The common sense solution says that let's forget about everything, sorting or anything, let's forget. The idea is, let us just try to have a look into all possible subsets that we can have, all possible ways we can have we can have m different packets out of the given n packets. Okay, we will try out all possible combination, and then we will distribute those possible combination to all the students, try to calculate the maximum minus minimum, and we will choose that combination which will give us the minimum. Okay, so naive solution is basically try out all possible. The naive solution basically says that try out all possible combinations. Okay, of m packets. Calculate your answer. Answer is basically the maximum value minus the minimum value, and choose that particular subset which is giving you the minimum answer. Okay, your question is done. Okay, but this will not actually help us in interviews, but this is just a common sense way. Can anyone tell me what exactly is the time complexity of this naive approach? Ashish, Rishabh? Yeah, Rishabh said that m choose n, which is equal to mcn, which is equal to m factorial minus m minus n factorial by n factorial. So this is the number of ways you can basically choose. In fact, it should be n choose m. Just a minute. It should be n choose m. Okay, you have got n packets and you're choosing m packets out of those n packets. Okay, m is always less than equal to n. Okay, so a slight mistake here. This should be n factorial into n minus m factorial divided by m factorial. Okay, so this is how, yeah, just let me know what do you think is the time complexity of the solution, of the naive solution? What do you think is the time complexity of generating all solutions? Can anyone tell me? M square, m square n m m n. No, no, no. These you see there is a factorial term involved in it. How do you think generating subsets take m square time? No, 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 not m square time. No, Deepak. No, Ashish. Anyone? What do you think is the time complexity of generating all possible subsets? If someone is just gave you a array of size n and it is asking you to generate all possible subsets of size m, so how will you think a little bit? He is saying n into 2 to the power n factorial into n. Okay, okay. You guys are like moving in the correct direction. You can even Google these things out. You will basically get to learn these as well at the same time as we are learning. So, can anyone tell me? Let's say, how many subsets are possible for a array of size n? Tell me this. Just how many subsets are possible for a array of size n? Pratik says 2 to the power n. Yes, Pratik, you are correct. So 2 to the power n is the total number of subsets. Okay. Yes, Ashish, 2 to the power n is the right answer. So think now, we don't actually need to create all the we don't actually have to generate all possible subsets. We just want to generate a subset of size m. Okay. Okay, so basically, what exactly it is happening here is that, do we need m subsets or m packets? We need yeah, we basically need m packets, but the naive approach is basically we generate all possible ways to select m packets and then we choose the best one. Okay, so I'm just asking what will be the time complexity? N minus m minus 1, yeah, exactly bound. Yeah. So let us have a look here. Just a minute. Let me just discuss. So let us say that you have a function, you have an array, and the array is 10, 20, 30, 40, and 50. Okay. Now let's say that you want to generate all these subsets of size 3. Okay. So let's say you take the first element as 10, then you can have 10, 20, 30. Then you can have 10, 20, 40. Then you can have 10, 20, 50. Okay, this is one of the ways to generate. Then you put 10, 30, and then you put 40, then 10, 30, and then 50. Then you put 10, 40, and 50. And then finally you put 20, 30, and 40. Then 20, 30, and 50. Then 20, 40, and 50. And finally 30, 40, and 50. So we 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. See, we generated 10 subsets of size n. And if you see 1, 2, 3, 4, 5, 5C3, 10, 11, 12. This is equal to 12, right? Hmm. Okay. So I hope this is clear. Hmm. Yes, Poonam, m into n ways, right? So basically 10. So in fact, what we are doing here is that we will basically be needing two loops, and then with the help of this we can have a calculate with to m into n will be our time complexity to just have a generate all possible ways, right? We stand here and then we try to generate the all the subsets starting with 10, then we try to generate all the subsets starting with 20, then we try to generate all the subsets starting with 30, 40, and then 50. In fact, we will not go to 40 and 50, 10, 20, and 30 will suffice, right? So this is the naive approach that I was talking about, and so yeah. But let's not just spend too much time here. The idea is that the time complexity will be n into m, but we don't want that. So what we will do basically is that try to sort this array. Okay. Why we will try to sort this array? Because we want to minimize our difference. Okay. So what we will do here is that we will first of all sort our given initial array. So after we sort this particular initial array, this is the array. So 2, 3, 4, 7, 9, 12, and 56. Now what we will do, we will try to look at every possible window of size m. Okay. So can anyone tell me if I am standing at an index I and I want to go, what will be the last index such that the subarray is of size m? Since the value of m is equal to 3, I want to choose all possible subarray of size m consecutive, all consecutive subarray of size m, right? Because the array is already sorted. I have sorted the array, and whatever happens, the difference between maximum and minimum, I will get the optimal answer in this fashion only. Okay. Hmm. So I hope everyone understood it, that why do we need to sort the array? Because if you sort the array, we don't have to basically travel across all possible subsets. We will just have to make one single pass and we will get our answer. Okay. Hmm. So the way I was asking is that, let's say if we have a array. Okay, so let's say we have input I, and we also have something. Yeah. So we have got an input index I, and the next index that will basically cover a subarray of size m will be I plus m minus 1. Okay, because we want to we want to include m elements into our subarray. And finally, what will happen? 2, 3, 4. Yeah. So the first subarray is basically 2, 3, and 4. The next subarray will be 3, 4, and 7. And the next subarray will be 4, 7, and 9. The next subarray will be 7, 9, and 12. And the next subarray will be 9, 12, and 56. Right. Hmm. So finally, what will happen basically is that I have generated all possible subarrays in a consecutive fashion. Now, what will I do? I will just compute the difference between the maximum and the minimum. Yes, Poonam, it's a sliding window concept only. But just let's just not say that term it as sliding window. We are just sorting it out and just applying our intuition and thinking that how can we get an optimal set of values such that maximum minus minimum is equal to is as minimum as possible across all possible subarrays. Got it? So if you guys are enjoying this particular session, just do a +1 in the chat box. We have two more problems to discuss, and we will wrap around in 1 hour or so. Okay. The last problem will be a hard problem. The second problem is a medium problem, and the first problem is an easy problem. Okay. So yes. So in the first subarray that we generated, the difference was 2. Then in the next subarray that we generated, the difference was 4. Then in the next subarray, the difference was 5. Then the next subarray, the difference is still 5. And in the final subarray, the difference is 56 minus 9, which is definitely a very big number. So we don't care about that. We got the minimum value in the first subarray. So we will be outputting the value 2. Okay. Thanks, Lord Pratik, Deepak. Okay, generally the last problem is take home. Okay, let's see what happens. Okay, I can do something like this. I will discuss merge sort in a very depth. I will discuss another problem called count inversion in a very depth. Okay, in a very depth fashion. And you can apply the concept of merge sort and count inversion to solve the last problem. Okay, in that case, just try to implement it. Okay, because the medium problem is also very simple and we can just do it. Okay, then let's have a let's see how it goes. We will then decide accordingly. So let's come back to our let's just try to write a simple pseudocode that will basically help us solve this question. So the code would look something like this. What we will do basically is that first of all we will sort. Okay. So if someone is asking you to sort, what will you use? Will you start writing merge sort code? Yes, Poonam, that's great. Really great ideology. So, just a funny question that if someone is asking you to sort a given array, will you start typing out the merge sort code? For example, in this question, you are given an array, and the first step that you have to do is sort. So, how will you do? Sort in STL, yes, of course. I don't know if anyone would write a merge sort code. Hmm. So basically, let's say you are given an array ARR. So we will sort ARR dot begin, comma ARR dot end. I'm just writing a pseudocode by the way. Okay, don't just start writing a merge sort code. Okay, I know this is a session for advanced sorting algorithms. Do not write merge sort code. Okay, just use this. After that, what we will do, we will declare two variables, start equal to 0 and int end is equal to 0. Okay, because we need to know the starting point and the ending point of our given subarray. Okay, and then what we will do, hmm, and then we will declare another variable called, let's say, difference. Okay, difference, and we will initialize it with max 1e9. Okay, this is basically int max. Why are we initializing it with int max? Because we want to minimize the difference, right? And every time we try to minimize the difference, we will try to that is the reason we are initializing it with int max. Okay, now what we will do, we will run a for loop from I is equal to 0 to I is how long we will run the for loop? Can anyone tell me? Can anyone tell me till what position I am supposed to run the for loop? Yeah, Pavan, exactly. I was just trying to add some humor. Okay, so I just said that it will be very funny if someone writes merge sort code. Definitely, no one will write. I know. Like, definitely, no one present in this audience will write. Okay, length minus m, n minus m plus one. Okay, n minus m plus one. Poonam is saying length minus m. Pratik is saying n minus m plus one. Okay, let's see. Which one will be correct? Yeah. So basically, I should iterate up to I should be less than n minus m plus 1. Okay. Why? Because I'm only interested in a subset in a subarray of size n. I'm only interested in a subarray of size n. So definitely I should have n minus m plus 1. Okay. If you just think a little bit, you will get to know that why I am doing this. This is not a very difficult thing to learn. After that, what will I do? I will calculate the difference. Difference will be the last index minus the first index. So the last index will be I plus m minus 1 and the first index is obviously I. Okay, so this is the difference. Now we will check whether this particular difference is less than, let me just write mdiff. Okay, this particular difference that we calculated is less than mdiff. Okay, this variable is different and this variable are different. So if this particular difference is less than the maximum difference we have, it means that we have reached an optimal answer because we are trying to minimize every point, right? So if we are reaching a particular value and if we are reaching a particular difference, which is definitely less than the difference that we have already run, so it means that we have reached an optimal answer and we should definitely store that answer. So what we will do, we will just update mdiff is equal to the difference start is equal to I or the value s is equal to I because I want to have the pointer start and the end pointer with me. I want to keep those pointers safe because I have to return an answer. And then finally we will have end is equal to I plus m minus 1. Okay, so this is the start and the end. And finally what we will do? We will return our answer. Can anyone tell me what will be the answer that we will return? I have already pasted the link in the comments of the problem. Tell me, what will be the answer? Hello Pavan, hello Pratik, hello Poonam, hello Ashish, hello Deepak. Deepak is saying AS2E plus 1. Like the question is asking us, I just have to return the difference. Okay. So the optimal difference. So the answer will be the array at end minus the array value at start. Okay. So after I run the entire loop, the whatever value I have stored in the start and the end are my optimal starting point and the ending point of the subarray. So that is the starting point will be the so I just have to make this particular difference end minus the start. Okay. A of end minus the start. This will A of end will contain the maximum. Okay, so A of end, this will contain the maximum value and this will contain the minimum value, and max minus min is our answer for this. Okay, so I hope everyone understood it. Can you explain the start is equal to I and end is equal to I plus m minus 1? Because in the question we are given that we have n different packets, but we have only m children and m is less than equal to n. So we have to always select a subarray of size m because we have only m students. We only want to distribute amongst m student and not more than that. Okay, I hope this part is clear. Won't mdiff also contain the minimum value? Won't mdiff also contain the minimum value? Mdiff is basically yes, mdiff will contain the minimum value. Okay, yes. Hmm. Yes, yes. Mdiff will contain minimum value. So this is basically the yeah. You can return that also. Yes. Okay. So yeah, we can return mdiff. Yes. So yeah, I just wanted to make you understand that yeah, the idea of start and end point, the value start and the value end. Okay, if someone asks you that instead of returning the difference, just return me the maximum and the minimum value in the optimal case. In that case, you would have to maintain a start and the end pointer. Okay, so that is the reason I just kept a two variable. It doesn't harm us too, but at the end the problem is solved. Okay, so let me just share my screen once again of the problem and let's try to solve this. Okay. Just a minute, let me share my problem wala screen and then um, thank you Deepak, thank you Ashish, thank you Poonam. Chocolate distribution, share. Yeah, so yeah, so we can also let me just control the. Hmm. So if even if you submit a of n minus a of start, the solution should work. And even if you submit m def, the solution will m in this problem the variable name is mind mind. Okay, so if I just write mind in this case, okay, the solution will still work. Okay, because both are the same thing. I hope everyone enjoyed this particular problem. Can I please have a plus one in the chat box if you have properly understood this problem? We will move to the next problem then. Okay, let's move to the next problem then. The next problem is a medium level problem, and let me just share the tab and the question link as well. So yeah. Okay, now Poonam wants me to distribute chocolate amongst you all. I'm not sure how can I do that virtually. Uh, Maybe you can ping me upon LinkedIn. You can just try to connect with me on LinkedIn, and if by chance, if we ever get to meet, remind me that I have to give you all chocolates. Okay, that's just a joke, in fact. Okay, so let's try to have a look here in this question. This is a very popular question, Mhm. So triplets sum in an array. In this question, you are given an array of size n, and you're also given an integer x. Okay. Now you have to basically just return yes or no. Okay. You don't have to return anything else. Just return yes and no. If you are able to find three values in the array such that the sum of those three values is equal to x. Okay. If you can find, just return yes. If not, just return no. Nothing else. Straight away. So what can you imagine? What can you think? The problem statement is just a one-line statement. Nothing very fancy about this problem statement. Now tell me, how will you solve this question? In the question, if you see in the example, we have n is equal to 6 and x is equal to 13, and the array size is equal to 1, 4, 45, 6, 10, and 8. So output is equal to 1 because yes, means you can definitely find a triplet 1, 4 and 8 such that this array sums up to 13. Okay. So in that case, in this case, the answer would be again 1. And in fact, if it happened that you have got an array, you are not unable to find it. So you will basically return no. Okay, return false. Okay. So just tell me, what do you think? Like, what are the first things that you are getting? Yes, this is the famous threesome problem on lead code. In fact, this is a famous problem is called threesome, right? Like there are very different variations of this problem as well. You can also be asked that you have to return the three. You have to return that whether you are able to form such that the sum is equal to 0, or in fact you have to return the total number of triplets, total number of unique triplets such that the sum is equal to 0 or sum is equal to x. Compare with a given sum. After finding all subset, we'll compare with given sum. Okay, you can do that, but but since that will be not very optimal. In fact, you have to try out some other possibilities also. We can use a last problem approach, and in every window of size 3, we add all the elements and check if it is equal to target or not. Okay. Okay, but you're thinking in a good direction, but that will not actually lead us to the answer. Okay. Just let us have a look into the constraints. Okay. So in the chocolate distribution problem, the time complexity of the problem was n log n because we used the n log n to sort the algorithm. Okay. In triplet sum problem, the constraints allows us the constraints are up to 10 to the power 3, and we are allowed a time complexity of n square. Okay. So we have to basically find a triplet such that a sum is equal to 10. Okay. Now, if you are just looking in this fashion, for example, if you're just comparing, you sort the array and you take the first three elements and you see that whether if it is equal to the given sum or not. And if not, you move to the next three element. This is a very wrong approach. This will not work. Okay. Because like if the first three elements are not working, then and you take the next three consecutive elements, it may or may not work, but we do not know. But there are many other ways that you are leaving out. There are many other possibilities. There are many other possibilities, subsets which you're leaving out. Okay. Yeah, we have to find a sum of three numbers such that basically we have to find those three optimal values such that sum is equal to x. But if we cannot just use the concept of the previous problem was a very easy problem. Just we cannot iterate over all possible subarrays of size 3. So you take the first three numbers and the next three numbers. We cannot do like that. Okay. Because we can do like that, it may give us the answer, but there are many other values which we are missing out, which can actually give us the answer. Okay. In the previous problem, we have to minimize the difference between the max minus min. So in that question, it made sense to actually use in that particular approach. But this doesn't ask us so. Okay. Optimal solution, we can fix one variable and for the other variables of B and C, we can use two pointer approach and see if the sum is equal target. Yes, exactly, Deepak. This is right in front of you, the code. Yeah, this is exactly what we are doing. Can anyone tell me a better solution? Like brute force sort and for every I and j, yeah, we can do that. Can anyone tell me an approach that uses map? If let's say if I'm your interviewer and I'm asking you a question that do this question but do not use two pointer, use a map. I want to use map. How you will do it? Can anyone tell me an approach of using map? In that case, there will be an extra time complexity. Hash set. Yes, like tell me the approach. Tell me the concept. How we will solve using map. Can be done by recursion. Well, may or may not be done, but why do you want to apply recursion when things can be done without recursion? Yes, we will be using hash maps, but tell me a concept. Okay, let me just share my iPad screen and then we will discuss various ways we can solve this question. Okay, so in fact, I will be discussing a naive approach, I will be discussing a better approach and an optimal approach. Okay, so and we will be submitting the optimal approach. Oh, sorry, I just reshared the screen. Give me a minute. Let me share my iPad screen. Make each element as key and remaining pair as value. Yes, exactly, Rishabh. This is the correct approach. And then we will try to find out that whether a particular value is present in the hash map or not. Okay, sort two pointers. Let's see, sorting and two pointers. I have already got a lot of value, a lot of comments related to that. And look for third in the hash map. Yes, Pratik works. Third in the hash map. So Pratik, can you tell me the time complexity of your approach? Poonam says that from the given sum, subtract one element and then find the two value by remaining array. Yes, exactly. We will be doing this. This is the optimal approach. Hmm. So, Pratik, tell me that what will be the time complexity of the comment that you just wrote? Okay. Okay. Okay, meanwhile Pratik is writing. So let's have a look into the brute force approach. So, like let's say that we are in class 9th or 10th, and we do not know about any optimization algorithm. We're just given this problem, and we are asked to write a code. Right? Okay. So the question says that we are given an array and we have to find three elements. So what we can do basically is that we can run three loops. Okay. So the basic idea is let's run three loops. Okay. What we will do, we will run a for loop for I. We will nest another for loop for j. We will nest another for loop k. So basically, we will go across all three values. Okay, we will iterate across all the three values, and we will check that if a of I plus a of j plus a of k is equal to given value x or not. If it is equal to x, in that case, we will just return true. Okay, we will just return true. Okay, so the time complexity of this approach will be big O of n cube, and we don't want that because big O of n cube is very expensive process. Okay, so and the question says that we have to do it in big O of n square, the expected time complexity. Okay, so we don't want that. This is a bad approach. Okay, so let's say someone in the comments said Pratik said that what we can do basically is that we take a element. Okay, so Pratik, where is Pratik's comment? Let me just have a look. Sort, then take two pointers, look for the third in the hash map. Yeah, this is a good idea. So what we can basically do is that we'll try to sort the element. Okay, so the idea is that once we sort the element, sorting an element in ascending order basically gives us a smaller element in the beginning and the bigger elements in the after that. Okay, so what we will do basically is that we sort our array. After that, what we will do, let's say we take the first element. Okay, and what we do, let's say, um, let me just triplet sum in an array. Let me just, okay, so let me just have a look into the one, two, three. Hmm. Okay. So this is the example problem 1, 4, 45, 6, 10, and 8. Okay. If I'm sorting this particular array, the array will become 1, 4, 6, 8, 10, and 45. Okay. So this is the array now. So it becomes 1, 4, 6, 8, 10, and 45. And then finally, what will happen? Hmm. So basically, let's say I take the first element. Okay, let me just name the variables a comma b comma c. I take the first element a is equal to 1. Okay, now when I take a is equal to 1, now I need to find the value. My target sum is basically let's say 13. X is equal to 13. It is already given in the question. This is the example from the question. So x is equal to 13. Okay. Now, what do we need? So let me just say I already have one. So I subtract 13 from 1. I get 12. Now I have to find two numbers such that the value is equal to 12. Okay. Now what I do? I take two pointers approach. Yes, exactly. We will be using sorting algorithms. Yes, exactly. We will be using sorting algorithms, and then definitely why we okay. So I take the value 12. After that, what will I do? Basically, is that So now what will I do? I will just take a pointer, two pointer. I will put on 4. And then what will I do? I will basically subtract 4. So 12 minus 4 will be 8. Now once I put up 8 here basically, then what will I do? I will try to find a value. So what will I do? I will try to find whether I have 8 present in my array or not using a hash map. Okay. So after that, what will I do? I will store all the values in the hash map, whether it is present or not, just the occurrences, right? And then we will try to find that whether 8 is present in my array or not with the help of a hash map. If it is present, I will just return a yes. If not, I will return false. In this, the time complexity will be n squared log n because we are just using a map, right? Okay, so this is just using the concept of sorting as well and idea of map as well. Okay, but we can actually optimize over this and prevent the use of hash map by using another concept. Okay, the concept of two pointers. Okay, so let's have a look into the concept of two pointers first. Can anyone just summarize me the concept of two pointers? Okay, so yeah, so let's have a look here. Just a minute. Yeah. So what we will basically do is that let's try to first of all we will sort the array, right? We sort our array, then we will try to run a loop. Okay, our loop will start from I equal to 0 to I is less than n minus 2 because we need to at least find 3 elements. Okay, so let's say what we will do, we will take two pointers, one at so one at the ith index and the other at the last index. Okay, so this pointer will be at an index I plus 1 and the R pointer will be at an index n minus 1. Okay. So this is at the I plus 1th position. Wherever I am just taking next position, and this is at the last position. So basically, if this is our array, this is my I am putting one pointer here and another pointer here. So I'm trying to find a optimal value in this particular part by keeping this particular part fixed. So what I'm doing, I am fixing my ith position, and after that I am iterating on I plus 1 to n minus 1 using two pointers. I am trying to find two optimal values such that the sum is equal to x. Okay, now how we will find that two optimal values? We have to basically use an intuition, use an idea. The idea is something like that. Let's say I have my I here, I plus 1 here. In fact, let me write L. Okay, L here and R here, right? We will be iterating across these two pointers. These are my two pointers. Two pointers basically help us finding two optimal values, right? These are my two pointers. Now I have to do something like this. I plus L plus R is equal to X. Okay, I have to do something like this. L plus R is equal to X. I is fixed. Okay, but this L and R are not fixed. L and R are variables. We can basically change them. Now we have to use an idea how we can change them. Let's say I plus L plus R is equal to X. This is the first condition. If let's say if I'm just I just put a value I, put a value L, put a value R, and I'm able to find it as equal to X. So we have hit the jackpot, right? We have hit a jackpot and we will just return true. But if not, there can be two conditions. The first condition is that I plus L plus R is less than X. If it is less than X, what does this mean? Can anyone tell me if it is less than X? Tell me, if it is less than X, what exactly does this mean? It means that I have to basically increment either my L or my R, the values present at L or R, such that it becomes equal to x. I want to add few values. Okay, I want to just increase the value. Okay, so in that case, what will I do? I will do an L plus plus, because see, L is present here, R is present at the end. I cannot increment R because it will overflow. I can increment L to the right side. Why? Because my array is sorted. I know if I increment L just by one value, I will get a bigger value. I will get a bigger value. And it may be possible that once I'm incrementing the value of L, I may get a value such that I plus L plus R is equal to X. Okay, listen to this very carefully, that if we are able to somehow get a value I plus L plus R is equal to X, in that case, we can just say, we will just be returning, hmm, got it? So if it is if it is less than x, we will just do L plus plus. Else we will do R minus minus. Else means if it is greater than x. If it is greater than x, it means that I must reduce one of the values of L and R. Okay, I cannot reduce L, or in fact I cannot reduce L, because if I just reduce L, it means that I have already been to that place. So instead, what can I do? I will reduce R, because initially I have taken I to the extreme left and L to the extreme left and R to the extreme right. Okay, and this is my I. I is always fixed, and I am iterating my two pointers on this. Okay, if I have got a value I plus L plus R as less than x, I will try to increment I so as to get a better value such that the sum becomes equal to x. If not, if I have got a bigger value, I have exceeded my value, I will try to decrease R. Okay, so this is the concept. I hope everyone understood this. Ashutosh, Pratik, Pavan, Shahid. So just have a plus one in the chat box if you understood the intuition behind the problem. Okay. Now what we can do basically, try to write a small pseudocode. In fact, no, doesn't matter because this is already a pseudocode itself. Okay. We can then directly jump to submitting this particular problem. And okay. So triplet sum. So this is a problem. Okay. I hope everyone can see my screen. I would That's great. Nikita, Poonam, Pavan, Ashutosh, Pratik. That's great. That's great. Okay, so this is a very simple question. Like this, the code is just a few lines. If you just count the number of lines, 1, 2, 3, 4, 5, 6, 7, 8, like around 10 lines code, and the complexity is n square. Okay, we would be making it complicated by using hash map. Okay, because the complexity would be n square log n, but just by intuition that we will increase the pointer if we have a if we will increase the left pointer if we have a lesser value than x. We will increase the r pointer if we will decrease the r pointer if we have a greater value than x. This is just a simple intuition behind solving this question. Okay, so let me just go and have drink some water. Meanwhile, you can also take a 2 minutes break. Just have a drink some water, and then we will continue with the third problem. Okay. So hi, I am back. Yes, Rishabh, you can use binary search in the inner loop. Yeah. So let us, but the point is that we are trying to do sorting algorithm questions. So we would be like binary search is we will be trying to do that in the next few weeks itself, right? So that is the reason I did not actually go there. Okay, so let's have a look into merge sort now. Uh, Let me just submit this problem and see whether it is correct or not. Now we come to the hardest part of the of this particular session. It is basically implementing merge sort. Okay, so I will show you the question, and then you can see that all the test cases have passed. So therefore, this question is correct. So now we this let's come to the hardest part of the hardest question. Let me share this tab. So yeah, so this is also a very simple question, just a one-line problem statement, but this is actually tagged as hard. And in fact, why it is hard? Because we have to actually write and implement a merge sort logic to solve this question. In fact, this question can be solved in a very few lines if we just try to apply the concept of binary search on this question. Okay, if you know the function's lower bound, upper bound, and what exactly does this function does, we can solve this question in very few lines, like 7 or 8 lines. In fact, we can solve this question in 2 lines also by using a data structure that not very commonly used. But in this particular session, we will be implementing a merge sort algorithm. Okay, so yeah, Pavan, I will just share it to you. Just a minute. So in this question, we are given an array of n positive integers, and we have to count the number of smaller elements on the right side of each particular array, right? So basically, it says that let's say you have got an array 12, 1, 2, 3, 0, 11, and 4. Now you have to count the number of elements which are smaller than 12 and are present on the right side of 12 in the given array. So if you see, all the elements on the right side of 12 are less than 12. So there are 6 elements. So the first value of the output array is 6. For the value 1, you see that there is only one element, that is 0, which is basically present, and which is basically lesser than the value 1, and it is present on the right side. Okay, and let's say if you have to for the value 2 it is 1, for the value 3 it is 1 again, but for the value 0 it is 0, because 0 is the smallest element and there are no element which are lesser than 0 present on the right side. So and so on, the question goes something like this, right? So what I am thinking about is that since we have a very diverse set of audience here, I will be discussing merge sort in detail, and I will be discussing a similar problem called count inversions, because these are very important problems. And then I will give this problem as a take-home problem. You apply those two concepts and solve those questions. Okay. Meanwhile, for the students who are much intelligent here, can you all tell me a data structure that can actually solve this question in 2 or 3 lines? Can anyone tell me? Let's see who can. A data structure. A hint: this is a very rare. This is a data structure actively used in competitive programming. If you do code forces, you will know this data structure, but you don't find that this data structure in C++ STL. Are we allowed to use array? Not allowing us array dot sort in GFG platform. I'm not sure. Like, um, you can sort this question, but you can use sorting algorithm definitely to sort this question. But actually, uh, the idea that I wanted to discuss in this session for previous problem. Okay, can you share the problem link? Yes, of course, I can share the problem link. Just a minute. There are various ways you can solve this question without application of merge sort, but I want to discuss merge sort in this session because the name of the session is advanced sorting algorithm, and I prepared a few content for merge sort. Okay, and I will be discussing a very similar problem called count inversions, which is very like if you are giving an interview, and in interview, let's say if you're asked to give given the question of count inversions, In that question, the interviewer would expect you to write the code for merge sort, because writing a code for merge sort actually tests you your merging logic, your recursion logic, and the way you actually implement the merge sort. Okay, it tells you that how in depth you can actually know your concepts. Okay, so back to my question: can anyone tell me a data structure that will actually help me solve this question in a very quick few lines? Okay, I'm not very proficient in Java, so that is why I cannot help you with Java code. But if you have a doubt in C++, do let me know. Okay, so this is a problem statement, but we will try to do a similar problem called merge sort. Okay, so let us first understand merge sort first, and then we will try to implement this. Okay, so to my answer, does anyone know about policy-based data structure? PVDS, also called PVDS, and there is a data structure called ordered set. If you use this data structure, you can solve this question in 2 lines. Okay. So this is not present in STL, it is present in PBDS, policy based data structure, which is basically an implementation of red black trees. So this is a bit advanced stuff, but let's study merge sort here. Just a minute, let me share my iPad screen and then we will continue. Okay, so let's see. Yeah. So let's have a look into merge sort now. Okay. So this particular merge sort algorithm is also called divide and merge algorithm. Okay. And the time complexity for solving this algorithm is n log n. Okay. Now let's say we are given an array. The size of our array is three. This is the particular array. So what we basically do in merge sort is that try to recursively. Okay, Pavan, let me just type it out for you. It is called policy based data structure. Okay, instead of typing, let me just write it on my screen. It is called mm, policy based data structure, and we will be implementing ordered set. With the help of ordered set, if you just Google this up, you will get to know it. It is very actively used in CP. If you try to solve code forces contest, you will get to know about this particular data structure. Okay, so this was just for not a point of our discussion right now. And I guess someone asked my LinkedIn profile. Let me just share it to you all, and then we can proceed. Okay. Yeah, I guess I just I actually pasted my LinkedIn in the comments. I think you guys can see it. Yeah. Poonam, priority queue. Like, why is this flickering? I'm not sure. Yeah, there was a slight problem with my casting of my iPad screen, but I guess this is working right now. Is that so? Can you all see my screen? I don't think so. Hmm. Okay, it's blank. Let me just reshare it. I think I hope everyone can see right now. Can you all can see the? I think it is visible. Okay, let's continue. Yeah, I have also pasted my LinkedIn, the particular link. Okay, so you can just have a, if you would like to connect with me, then that would be really great. Okay. Hmm. So let's continue. Yeah. So this Pawan was asking for the ordered set thing. Okay. So this is basically a policy-based data structure, and it's kind of advanced. So let's not go into them. Okay. So let's have a look into the idea of merge sort now. So merge and merge sort is basically divide and merge algorithm, and the complexity is basically n log n. Okay. Okay, so complexity is n log n. So what we basically do, we are, let's say, given a particular array. So let's say we are given this particular array 3, 1, 2, 4, 1, 5, 2, 6, and 4. Okay. So what we do, we try to split this particular array into two parts. This is the first part, this is the second part. Now recursion, so basically we are splitting the left part first. So what will happen in recursion, when we split the left first, it goes recursively calls for the next left part. So this will be again split 3, 1, 2, 4, and 1. This will again be split into 3 and 1 and then 2. And the left part will be split into 3 and then 1. Okay. So this is how it is splitting. Okay, the left part gets split first, then the right part. Okay, this is how recursion works. So when the size of the array becomes 1, like we can keep on continue splitting, but when the size of the array becomes 1, in that case, we can no longer split. Okay. So what we will do, we will try to merge them back up. So we start merging them, but there is a condition of merge. We will just not simply merge it back the way we split it. We will merge it back in a sorted fashion. Okay. So when I'm merging 3 and 1 back together, instead of 3 and 1, I will put 1 and 3 together because 1 and 3 is in sorted fashion. This is how it works. Now I have 1, 3, and then I have got 2. So these two are sorted arrays. Now what will I do? When I merge two sorted arrays together, I have to make sure such that I have to make sure that the arrays are basically sorted. So every two sorted order, the merge logic should be in such a way such that it takes two sorted arrays and merges it back in sorted fashion. So this will be 1, 2, and 3. We will discuss the merge logic as well. So how we are exactly merging? We are basically merging. We are standing on, let's say, 1, and then we are standing on 2. We are comparing that whether 1 is less than 2 or not. If 1 is less than 2, we put 1 into our merged array. Then we move to 3. Then we check whether 3 is less than 2 or not. 3 is greater than 2. So instead of 3, we will put 2 because whatever number is less, we will put first, and whatever number is greater, we will put second. So this particular array is done. Now we are left with 3. We'll put up 3. So this is the merge logic. Okay. Now, when will you merge? Okay, the question is when will you merge? When both left half and the right half is sorted, we will try to merge. So the idea is that we keep on merging smaller elements and make it sorted. So whenever the left part and the right part is sorted, we will merge it back together and create a new sorted array. So this is the entire logic of merge sort. Okay, so we will try to merge. Let's try to implement the merge logic, right? So what exactly is happening in merge sort? So let's say we have got basically two pointers, right? So let's say we got a particular array here, we got a particular array here. This is array A, this is array B. Okay, this is a sorted array and this is also a sorted array. Now what I'm doing here is that I'm putting two pointers here. Okay, this pointer will be, let's say, I, and this pointer will be, let's say, j. I'm comparing the two values. If the values, if let's say I is less than j, I will put the value, this particular value here, include it in my merged array, and then move the pointer here. Again, I will do the same thing for these two values. Whichever will be less, I will put it and increment the pointer. Okay, so this is how the merge logic will work. And the complexity for merge logic will be O of n1 plus n2, because I am just iterating across both the sorted arrays at once. Okay, so let's have a look into the merge sort logic. So how exactly are we going to look into the merge sort logic? Let's say we take a smaller array for better understanding of the question. This is our array. So the array elements are 3, 2, 4, 1, and 3. There, I have already mentioned the indexes also, indices. We will initially have a low value, low will be equal to 0. And we will also have a high value, high will be equal to the last value of the index, okay, which is equal to 4. We'll call a function called merge sort. We'll try to implement. We will pass our given array. We will pass the low value. We will pass the high value. Okay. And then what we will do, as I initially said, merge sort is a divide and merge algorithm. So what we will do, we will try to find the middle value because we want to split it. We want to divide the array. Okay. So middle value will be low plus high by 2. Okay. So I hope everyone is with me. Okay, now what we will do, we have segregated our merge sort into two parts, the left part and the right part. Now what we will do, we will send recursively call the merge sort function once again with two indices. The first one will be low and the next one will be mid. Why? Because if this is low, this is high, low plus high by 2 is actually giving me mid. So 0 plus 4 by 2 is equal to 2. So this particular value is mid. So I'm taking the first three numbers in one part and taking the next two numbers in the different part. So 3, 1, 4 and 1 and 3. These are the two splits that I have made. And this particular split is receiving 3, 1, 4 and this particular split is receiving 1 and 3. Okay, so low and mid. Low basically contains the first index. Mid basically contains the index of 3 to 4. Okay, so 3 to 4 and 1 and 3. Okay, now what I am doing, I am recursively calling the function to split the array into two parts. Now this will recursively call to split the array into 3 to 4. Okay, so if I just write a logic here, what will happen? 0 and 4 is the indices. It will split into the next split. It will again split into 0 and 1. And finally what will happen? 0, comma 0 and 1, comma 1. The size of the split become 1s. So the base case, it brings me to the base case now. So the base case of this particular recursion will be when the size becomes 1. Now what happens when the size becomes 1? When the size is becoming 1, low is equal to high, or in fact we can write low is greater than equal to high. Okay, because in that case the size is becoming 1, right? So we will just return. It means that the size has become 1. Now it's time to merge the two arrays. Okay, whenever size become 1, we can no longer split, we will merge it back. So at this point, we got a size is equal to 1. Now what will happen? We have written a merge logic also. This merge logic is taking three parameters. The first is low, the mid, and the high. It is taking the starting index, the middle index, and the high index. So basically, I have the indices of the positions I want to merge. So I want to merge from low to mid and from mid plus 1 to high. Okay, so these are the two positions, from low to mid and from mid plus 1 to high. So that is the reason I have already from low to mid and from mid plus 1 to high, these are sorted now. I hope everyone here knows about merge sort. So this is just an explanation. Okay. Now what will happen? We merge these two arrays. Now let's have a look into the, I have already discussed the question. So if this is our two sorted arrays, what we will do? We will try to merge it. The first pointer will be low, this pointer will be mid, the third pointer will be mid plus 1 and final pointer will be high. So what we will do, we'll create a temporary array. The first step is to create a temporary array. Then we will declare two variables. The first will be left. Left will be equal to low and right will be equal to mid plus 1. Why? Because we want to have two pointers as I just discussed. After that, what we will do, we'll run a while loop. Now while loop, basically left will be less than equal to mid and high will be, right will be less than equal to high. Okay. Now what will happen? I will just try to check whether the left value is less than or equal to the right value. If it is, I will add it in my temporary array and do a left plus plus. If not, I will add it in the right value and do a right plus plus. Same thing will go. After I am done with this, I will just check that whether there are any leftover elements in either of the arrays. Okay, if there are any leftover element, so if we have leftover element in left part, then we will add those. If we have leftover element in the right part, we will add those. Okay, and finally what we will have, our temporary array, we will put it back in the original array. Okay, because I have actually merged these two parts. Okay, so this is the idea of merge sort, and the complexity is basically n log n. So I hope everyone understood it. Let me just share my stop the screen sharing, show a merge sort code to you, and then we will continue. um, yeah, yes, Ashutosh, I will accept your connection request. Ashutosh, okay. So yeah, so can I please have a +1 in the chat box if you have comfortable with the merge sort code? Let me know. Okay, yeah, that's great. So what is happening here is that so this is exactly the conditions that we have put. Let's just, this is the merge sort logic. We are dividing into middle. We are then sorting the first part, sorting the next part, and then merging it back together. This is the merge sort logic, right? So this will sort in ascending order. Let us just submit. Okay. Now we'll do a similar problem called count inversions. Okay. Now using the concepts learned in merge sort, using the concept learned in merge sort and the concepts learned in count inversion, we will be able to solve that hard problem. Okay. Can you explain the non-recursion algorithm of merge sort? Yes, I can explain, but that's not in the agenda today. I would recommend you to have just read the Geeks for Geeks article for the purpose. We do have a non-recursive algorithm, but understanding the recursion algorithm is actually quite helpful. Okay. In fact, now let's say you are given this particular question, count inversions. Okay, so in this question, this is a very famous problem and it is very frequently asked. Okay, uh, Arushi Tomar asked me about iterative merge sort. I'm just giving you a Geeks for Geeks article for the same. Okay, in fact, if we have time, we'll go through this article and then I will try to make you understand. But let's have a look into this question. It says that we have to count the number of inversions. Inversions basically means that you're given an array and you have to basically count the number of number of pairs I comma j such that a of I is greater than a of j for all possible I and j, such that I is less than j. Okay, so this is the inversion. Okay, in fact, I say you that if we make a one-line change in the merge sort comment, merge sort code, we will be able to solve this question. We have to just count the number of inversions. Okay. Yes, exactly, Pratik. You're correct. Modify merge to get the number of times the element from the second subarray is smaller than the first subarray. Okay. Okay, so this is the question. Let me just give you the link and then I will back share my iPad screen and then yes, Pratik, you are correct. So what exactly is happening is that we have written a merge logic, right? So what we are comparing whether the element on the left part is greater than the right part or not. If it is greater, what we are doing, we are just showing the smaller part. But let's say whenever an element is greater, whenever an element in the left part is greater than the element in the right part, it means that that is an inversion, right? That is a valid inversion. So what will I do? I will count all the element after that because since both the arrays are sorted, so all the elements after the element in the left part will be basically a valid inversion for the element in the right part. Okay, So let me explain it to you in the form of with help in my iPad, and in that case you will get to understand it better. So count inversion is basically you have to find the number of pairs. Okay. So let's say you have got two sorted arrays. This is a sorted array and this is a sorted array. Okay. And let's say you are standing on 3 and you are standing on 2. Now you see that 3 is greater than 2. So it means that 3 is a 3 comma 2 is a valid inversion, right? So what you will do? You will do a plus 1 in your answer. But doing a plus 1 in the answer won't help because the two are already sorted. So what happens is that all the numbers after 3, I repeat, all the numbers after 3 are also valid inversion for the number 2. So instead of adding plus 1, I will add all the numbers after 3. So 3, 5, 6, which is basically plus 3. Instead of plus 1, I will add plus 3. Okay, because brute force way of finding the number of inversion is something like this. We stand at 2, we go across all the values and see if it is less than 2 or not. We stand at 3, we go across all the values if it is, and try to find all the values lesser than 3. We stand at 5, go across all the values. We stand at 6, try to find all the values lesser than 6, and then increment the count. Okay, so this will basically take an n square approach. But since both the arrays are already sorted in merge sort, when we are merging them back together, we can just count the number of inversion at that particular step only. So what we will do, we'll declare a global variable count, and then what we will do, we will just do count plus equal to mid minus left plus 1. Why mid minus left plus 1? Because this particular is low, this particular is mid, and this is left. So mid minus left plus 1 will give you all the numbers after left and in that particular array. So what we will just write this particular line of code, it will help us count of all the smaller number on the right side. Okay, so this is the only modification that we have to make such that we can count the number of inversions. Okay, so I hope you guys understood this question. Okay, so let me just share my screen. Yeah. So this is the count inversion code, and if you see, I only made one particular change in this particular code, and it is equal to this. I declared a value called long count, and in this, I just made this particular change. Whenever the left part is greater than the right part, it is a valid inversion, and I'm just counting all the count that is possible from that particular value. So let's submit this problem. So now you have to basically utilize these two concepts to solve the question on count smaller elements. Okay. So can anyone here tell me how exactly are we going to utilize these concepts to solve this question? Anyone? Pratik, Ashutosh, Pawan, Poonam, Nitesh, Arushi, Pratik. Yeah. So the idea is very simple because in this question you have to basically return a particular array that will contain all the number of all the elements which are basically on the right side, and it is smaller. So it basically means that some way you are basically storing all the inversion itself. Okay. So if you just add all the elements 6 plus 1 plus 1 plus 1 plus 1, it is basically giving you the count of inversion. The sum of this array, whatever you are returning in this count smaller elements, is basically the total number of inversions in the array. So instead of just counting, doing a count plus equal to, you store it in a particular array called count. Okay. And try to implement this logic. I am sure everyone can do that. Ordered set approach, of course, Pratik, I will share it to you. Just a minute, let me just open that question. Uh, okay, in fact, if we just have a look into the editorial code, I think the editorial code, the person who has actually authored this question has made it in such a fashion. Okay, so if you just have a look into the editorial code itself, it's written in order set. Because I think the problem setter, the person who actually set this problem on Geeks for Geeks, did not actually wrote a merge sort logic in the backend. He actually wrote the ordered set logic. Okay. Yeah. In fact, if you see other people's submission for this problem, you will be finding that many people are using lower bound, upper bound. These are binary search techniques. But actually, I wanted to discuss how you will apply merge sort. Okay, because sometimes in interview, writing a very short code will not get you actually. The interviewer expects you to write very optimized, well structured, clean code, and he or she will mention you that if you can do it in n log n, right, do a merge sort logic because he wants to know that your concept of merge sort is correct. Okay, but if you're doing a contest, you don't want to write a merge sort code. You will use ordered set, or you will use a lower bound or upper bound function to get quickly to the answer. Okay, so the driver code is already the my merge sort question. Yeah, it is not an algorithm. It is a policy-based data structure. Okay, that is very commonly used on code forces contest. Okay, you don't have to learn. This doesn't actually help in solving lead code or internship questions, but it will help you solve code forces contest very well. Okay, so I'm submitting this problem, and if I have already given the link of this question in the, you can have a go and have a look at my submission for this particular merge sort code, and you can try to understand that how basically the two concepts of merge sort and counting the inversions are being applied here. Okay, I hope everyone enjoyed this session. We started with around 50 plus students being at my session, and then we have presently around 20 students. I hope everyone is enjoying this particular series. Today is the seventh day. We have 14 more days to go. And from tomorrow onwards, Siddhartha and Yash will be continuing with this particular series. And if I get a chance, I will once again come back. Okay, and if once again, let me just introduce myself. My name is Gaurav Kumar Shaw, and I will be in my final year very soon at IIT Kharagpur. Do hit me up on LinkedIn if you would like to talk to me. Okay, that would be really great. I have given my LinkedIn grade. Great session. Thank you, Pavan. Thank you, Prateek. Okay, amazing, maza aa gaya. That's great. That's really great. Today is actually Friday night, and I really enjoyed spending 2 hours, like 2 or 3 hours. I prepared for some content here as well before, and right now, in fact, I am in at my office. Okay, so if you right now I'm streaming it from my office. I was actually today's a working day, so uh, after work I actually went across and saw the questions and prepared a few content, and right now I'm just streaming it. Okay. In fact, this is the culprit office. Okay, thank you, Ashutosh. Yeah, see you. Yeah, have a really, really great night and do enjoy your weekends. Okay, and definitely turn up for tomorrow's session as well. Should I learn Flutter, sir? Please reply. Why would you learn Flutter? If you are interested in app development, then you should learn Flutter. But if you want to get into a company, then you should learn DSA and comparative programming. Okay, development doesn't really actually help in landing a job, but DSA and CP will. Okay, that is great. Okay then, bye bye. Have a great night. Have a great weekend. Enjoy.